Guys, and then I got burnt out with parents. Ouch. Still on.
All right, happy Tuesday. How's everyone doing? Great, good to see everyone. Did I tell you I had a child over the summer? Isn't she just absolutely adorable? What a person. Well, good to see everyone. I hope you're staying warm. A little bit hard to do these days, but totally doable, especially in this room. I've found out. I made the mistake of wearing 2 layers again today. Won't last all class. So good to see everyone. We have a big one today, or like a medium big one. We're going to start by talking about categorical variables, just thinking about some best practices for doing data summarization, primarily through visualization. And then the back half of class, we're actually going to start working with a data set. And we're going to do this in 2 ways. First, I'm going to show you how to do a data summarization with Excel. So this is the more standard tool. It's sort of like the easier one to get started with. So I want to show you some of the basic skills in Excel. But this class is primarily done through Python, so I'm going to show you 2 methods for doing the same thing. I'm going to show you that they are the same tools, same steps, and all of the sort of the back end is all the same. Except Python is going to be much simpler. So we're going to do the same approach 2 different ways. We're not always going to do this, but at the beginning of the semester, I just want to show you the similarities between the 2 tools, and that one actually turns out to be same steps, but easier. So that's where we're going. I'm going to ask you a lot of questions over the semester. A lot of those questions are going to start today. So what we've done so far is just sort of introduce the kinds of things we think about in economic data. Actually, before we get started, there are a couple of housekeeping items. So we're going to have our second exercise today. We'll have our third exercise next class. Our first homework is due at the end of the week. So homework 1.1 and 1.2. Someone get the door. Those will both be due on Friday. As always, if the timing feels too quick, like if you need extra time, just send me an email. No questions asked. I will just say, you got it. And you have an extension through the weekend. That's always there for you. I don't want you to have to feel rushed to get the work done, but I like to give you a clear deadline just so you can feel some pressure to get the work done before the weekend. But if you need more time, just ask for it. So homework 1.1 is posted. Homework 1.2 will be posted around class time on Thursday. So often the second homework of the week will feel like a quick turnaround, which is part of why I like to give more time if you need it. So you'll be able to find the homework. The document is going to be on the course website, so let me show you where that is. So you'll just go to the course website. So this is the content for class today. When I record a class, I'll post it here. When I record the concept before class, I'll post that recording here too. You can find the slides, interactive notes, all of that here. The exercise we're doing today with coffee shop locations is here, so that'll be the notebook and then the coffee shops data set. And then homework 1.1, so that's due on February 23rd at 5 p.m. You can find the assignment here, so if you click on that, you can find the assignment. We're going to talk about notebooks today, you'll use a notebook for your first homework. So that'll be the one on Friday. And then if you want just to look at the data set with the survey, you can find that here. So I just pre-processed everything, all anonymous, but I have the survey, which you can take a look at. And you're going to actually be working with this in the homework. All right, so that's the homework. And then to submit it, you'll go to Gradescope, and you can submit it here. So this is the link, and then you just go through and enter your work. Any questions about that? Okay, so if you ever do have questions, just send me an email or come knock on my door. All right, so we have a medium big one today. We're going to start talking about our first variable type and get into summarizing it. In part one, we're really just focusing on variable types and doing the summarization. So in a lot of ways, this is gonna feel like kind of low stakes. We're not doing anything incredibly fancy. What I introduced to you last class was this amazing study looking at the effect of minimum wage. And you'll remember, we went through this whole process of describing the data, of thinking through the implications of minimum wage hikes, and the economic theory that would predict what actually would happen with our data. The realization with economic data is we have these models. We have these predictions about what happens directionally with things like minimum wages and labor demand coming from firms. But what we do in the field is actually go out and validate what the predictions would tell us. We would check whether the predictions hold in real life. So we went through this amazing data analysis story. There's a lot of details that the authors of that study had to go through. There's a lot of details involved in working with data. And in a lot of ways, part one is really just about the basics of getting started with those details. There's a big framework, and we're going through the framework step by step. What we're doing today is really the first step there. We're going to try to summarize categorical variables. So I'm going to give you some questions, and then you're going to tell me what you like better. The core idea with what we're doing, particularly today, but also over the next 2 or 3 classes, is it's very difficult to understand data without summarizing it first. So we need some way of summarizing our variables that makes it easier for us to understand what's included in them. And a big part of what we're doing is that the tools we use to summarize a variable depend on its variable type. So we went through this whole diagramming exercise last time because the place to start is to diagram the data. And then, once we have the diagram, we can match the summarization tool to the variable type. So we're going to start with our first variable type today, which is categorical data. And we're going to talk about best practices for visualizing it. Okay, so I'm going to show you a data set. This is on coffee shop locations. I have a data set, it's fake, but we're going to talk through it anyway. And my question, essentially, the first question I'm going to ask you, I'll ask a couple of other questions as well. Which coffee shop has the most locations? So this will be the first question I ask you. And when I ask you, well, we'll get there in a second. This is the first question we're interested in. And this is one thing we could do with the data set, right? I could just, instead of, this is a bunch of coffee shops. And I don't have identifiers for the different coffee shops, but we know that they're all in different states. So I've just listed each shop's state in a list. So I've just left off the index variable. What do you think? Which state has the most shops? Yeah. Is it Kyle?
Casey.
Casey, sorry.
California.
So of the shops, of the states we have here, I mean, California is definitely listed, but it's sort of hard to tell which shop has, or which state has the most shops, right? Like, we have California's at the top, so maybe we would say that has the most if these are just ranked. But what this is telling us is just a list of all the states with a shop in it. Yeah, it's nice. Is that a?
I was going to say because they're more of a business in the city and those monies, and that's.
Oh yeah, so maybe we're actually pulling from sort of outside information and saying, yeah, like New York actually has a huge city in it, and so maybe there's more coffee shops in it. And maybe the same idea with California. It's like it's just a huge state. California is the largest state by population, and so maybe we just know from outside that it has the most coffee shops. But just simply using the data that's in our data set given to us here, I would say it's pretty hard to tell. Right, we have one row for each coffee shop, and then we're just listing out each of the coffee shops. We could go to the data. So this is another thing we could do. Oh, look at that cute picture. So we could go to the data set and just look at the data set itself. So here I have exercise 1.1. I can click on it, and I can pull this up. So here I have a list of all the coffee shops and their states represented. And so I could just look at it, right? This is a small enough data set where I could probably just figure it out. Yeah, so turns out we know the answer. It is California. But this is a hard way to understand data, right? To look at the data set and try to just count out all of these things. We have computers that will do this work for us. But we have to figure out how to use the computer to tell us what to spit out. We have to learn how to have the computer do the work for us. This is the tool we're working on in parts 1.1 through 1.5. Okay, so I'm going to ask you a bunch of questions. We know the data set it needs to be summarized. Summarizing this data will make our job a lot easier to answer this question. So I'm going to give you two figures. I'm going to give you 10 seconds, and you're going to tell me which of the two figures is easier to read, and then I'm going to take a poll. Ready? All right. Which state has the most locations? Okay, so we know the answer to this question, right? Casey actually already gave it to us. My question for you is, which of these two figures was easier for you to read to answer this question? Kind of a meta question. How many of you prefer the bar graph? How many of you prefer the pie graph? Okay, so I'm going to ask you for your some explanation here. So if you prefer the bar graph, why? Yeah.
So since the question is just asking which state has the most, with the bar graph, you can easily see that the red bar for California is not furthest to the right. Where with the pie chart, you kind of have to look at all the other ones to make sure they're not bigger than the California one.
Yeah, nice. Remind me of your name?
Ryan.
Right. So Ryan's saying, look, a bar graph, you can just like look on the horizontal axis and see which bar is longer. So sort of easy to see the horizontal. Where a pie graph is a little bit maybe more challenging. Yeah, what else?
I tried to use to show the percentage of a whole, which isn't really appropriate here.
Okay, so this is a bit of a like foreshadowing for where we're going. But we can, one of the tools that pie graphs are especially good at is showing percentages of a whole. And here, we're not asking a question about what percentage of coffee shops are in the largest state. We're asking a question about which state is the largest. And so maybe that kind of rules out a pie graph. Yeah, remind me of your name? Maddox, that's right. And Ryan? Okay. Any other observations here? Yeah.
Right. Well, I chose the pie graph.
Yeah.
I don't know which one is right
for like certain types of data, but
Yeah.
it was the same exact reason he said. It's just like easier for me to read. I think I was looking for like whichever one is largest. I can read that easier like on a circle.
So yeah, so this is really good. Remind me of your name?
Jackson.
So Jackson is saying he doesn't know which one is right, but he was looking at the two figures, and this one just seemed easier. And the short answer to everything we're about to do is that there aren't right answers. The right answer is the visualization that's easier for you to read. So in this case, I mean, that leaves it sort of subjective. We have some best practices, but the answers to what I'm about to ask you are all subjective. So Jackson is saying, for him, actually, this is, the pie graph is maybe easier to read. Yeah, so that's great. Any other observations? Yeah.
I was just imagining, like, since it's talking about states, if this was extended to like the whole entire US,
Yeah.
it would be easier if it was a pie chart, because then you wouldn't have to read through 50 columns.
Yeah, so this is a great observation. Remind me of your name?
Katie.
So Katie's saying, we have 5 states here, but what if we had 50? In that case, a pie graph is actually very challenging to read. And a bar graph would be basically as easy as this. It would not be noticeably more difficult. So in small numbers of categories, maybe pie graphs might be doable, but in large numbers of categories, bar graphs are just going to clearly be better. Any other observations? Yeah.
I was thinking if the values were, I guess, larger. For example, if the coffees in each state were larger, then you might need to like maybe skim across the entire column to get to like, the state. On the other hand, with a pie graph, it's right next to the pie itself, so you don't have to look across the screen to find out which state it belongs to.
So yeah, so there's maybe something with the labeling that makes pie graphs potentially a little easier, in at least the way we've done it. Yeah, so the idea is like, okay, we put California right next to the thing that we're checking. So the label is close to the number or the size. But here, we have to check all the way out here for the height of the bar. And then we have to look all the way back, like follow the line back to the California. So there's almost like 2 steps visually. So yeah, something to think about when we're setting these things up. Notice where your eyeball moves to. These are subtle observations, but these are the kinds of things we think about when we create good visualizations. We want the audience and their eyeballs to not have to do too much work. Even though it sounds funny, thinking about these things makes what you're communicating much easier. And the easier it is for your audience, the better. Think about this. You listen to me talk for what, an hour and 15 minutes twice a week. You can't follow everything I say. I was a student once. I got lost in my own head half the time. Part of good communication is just having your audience track what you're doing. And the easier you make that for your audience, the easier it is for your audience to stay on track. And that's half the battle. And creating good visualizations is a big part of doing that. Minimize the cognitive load of what your audience has to do with the visualization. Any questions? Okay, so I think in general, both of these are fine, easy enough to see. They're easy to answer both of these questions. But I'm gonna ask you a second question, and this will, I think, really bring out some of the details here. Does Florida or Washington have more shops? 10 seconds, and then I'll ask you which one you prefer. Florida or Washington have more shops? Okay, for this question, how many of you prefer the bar chart? And how many of you prefer the pie chart? Okay, so I'm gonna get your perspectives in a second. I think nearly everyone in the room prefers the bar chart. Someone want to tell me why the bar chart was so effective for you? Right.
Yeah, for this one specifically, the colors of Florida and Washington are pretty close. So I feel like having that white bar in between where I can see the significant drop off is a lot easier for me than trying to compare the two, like the similar wedges.
Okay, so a couple of things here. One is the color between the two states is pretty similar, which turns out to be pretty difficult to see on the bar chart. Sorry, on the pie chart. Where on the bar chart, it doesn't really matter. All we have to look at is this difference in the length of the bars. So the color matters for the pie chart, but it doesn't really matter for the bar chart. So kind of makes it the easiness of interpreting the figure lean towards the bar chart. Some other observations for the bar chart? Yeah, Max. Sorry, Jackson.
Yeah. Okay. I think just like trying to find Washington and Florida is easier on the bar chart because we have to like go in a circle looking for like the state. Just to break down the list.
Yeah, so instead of looking in a circle, we're just looking vertically. And for the movement of our eyes, that's almost simpler. Yeah. Yeah, what else? Yeah.
For the bar chart, there's intervals, so it's like you have to see what interval is in between, whereas the pie chart is really just in there.
Yeah.
So in that case, I voted for bar chart, but I
Yeah.
thought pie chart was
Yeah, so remind me of your name?
Ira.
Ira. So Ira's saying even though like the bar chart seems to be easier to read, one thing in favor of the pie chart is we actually have numbers listed. So to interpret to answer this question, if you're asking like which one of these two states had more, or like what the count is for Florida, for example, to find that number, we'd have to find Florida, run our eyeballs out to the end here, run down, and then run back up to figure out the count. Where the bar chart, or the pie chart as we've done it here, we can just look at the number and it just tells us what that number is. So that's something we'll come back to actually. It's a very interesting observation. What else? Okay, so contrarian opinions over here. Anyone want to represent why you prefer the pie chart?
Yeah, the numerical values are in each slice, so it makes it a lot easier to just compare which one's bigger. Like, you see two different.
Nice. So yeah, so similar to what Ira was saying, we have two numbers for each of the states, and so we can just see the numbers and compare the numbers directly without doing any sort of visual work. Yeah. Okay, so you're going to create visualizations this semester. You're going to find a data set, and you're going to use that data set to construct visualizations. By the end of the semester, you will feel comfortable doing these things. And as you're doing those visualizations, you'll be thinking about the best way to display that information. So these are some things to think about. For me personally, I think whenever you're displaying multi-categories like this, a bar chart in general is going to be a lot easier, partly for this reason. Comparing relative sizes is just very simple. But a few people were pointing out there may be ways of improving these figures. So if I were to ask this question, how many shops are in Florida? Give you 10 seconds. Which figure is easier? Okay, hands for bar. Hands for pie. Someone want to tell me why? Like 3 people who went for bar. Yeah, James.
Well, I said bar only because it's whole numbers. If these were not whole numbers, like they were decimals, then the pie chart would be easier. But I think the logic for why bar has been easier for me the whole time is consistent. So
Yeah.
you just look after the thing you look up. It's right there.
Yeah, nice. So James is saying very consistent story for him. It's a sort of systematic way of reading a bar chart, and not a lot has changed here. partly because we're dealing with whole numbers. Any other opinions here? I mean, a lot of you voted for pie charts in this case. Why is that? Yeah.
Well, for one, the bar graph doesn't have like number where Florida hits. So I had to count like between 2 and 4, which I know sounds
Yeah.
ridiculous, but like it's so much easier on the pie chart to just look and see Florida 3, and
Nice.
then that's
Yeah, remind me of your name.
Jaden.
So Jaden's saying, I have to look at Florida, I have to run my eyeball out, find where the end of this bar is, run the line down. I don't see a number on the horizontal axis, which might be a problem with how I've created this visualization. It may sound funny, right? Like that was the comment, but I actually agree. Like those subtle things truly do matter. There's no 3 here. And so I have to infer that this is halfway in between 2 and 4 at 3. Where with the pie chart, I can just see Florida's. Okay, a lot of subtle details. But we can actually make a bar graph easier to read in this way. One thing I can do is just put some numbers on the bar, just like I did with the pie. And that's not too hard to do. And I think this improves the figure. In fact, a lot of times you'll see bar graphs done this way with the, I'm in a weird part of the algorithm on YouTube. I get like science communication, like that's my entire algorithm. And every time I see a bar graph, it has the number on top of the bar. Because effective science communicators know these things. Another thing we can do, now with our bar graph, we have duplicate numbers. So we have 4 here and we have 4 here. So another thing we can do is just pull out the horizontal axis. So now we've removed the duplicates. So another best practice is that we remove as much clutter as we can. If there's anything extraneous, we take it out. Almost like in a brutal way. Like you pull out as much as you can from the figure and leave only what truly matters. Okay, any questions here? Anyone disagree with that? Going back to Jackson's earlier observation, there aren't hard and fast rules. Like there's no correct answer to a lot of these things. A lot of the stylizing will be subjective. But these are just some of the best practices. And for me, I would pull the horizontal axis off. Okay, any questions? What if I were to ask you for how many shops are in the state with the second most locations? Take 10 seconds. All right, hands for bar, hands for pie. Oh, interesting. There are more hands with the pie chart. To me, this one is the most in favor of the bar. Someone want to represent the pie graph? Why this one?
Again, I just look at like the numbers and see if the second highest number is.
Okay, so yeah, maybe because it has numbers. Although in this case, both have numbers.
Yeah.
So.
I don't know. It's just like I kind of look at like at the pie graph. I kind of look at California first because it's the biggest.
Yeah.
I go to Texas, which is like at 4, and I go like the rest are smaller.
Yeah, so maybe because it's ordered,
Yeah.
then it's easier to read. Yeah, remind me of your name?
Asia.
AJ, yeah.
I was just kind of gonna say like they're right next to each other on the photograph, and like it's very easy just to see how it like kind of goes and
Yeah.
not separated.
Yeah, so ordering, there's this sort of consistency. Ordering, particularly the pie graph, makes it easier to read for this kind of order question. Remind me of your name?
Layla.
Layla. So what if we order the bar? So if I just move the bars around, I think this is the final form for me of a bar graph for this question. If you ask me to create the best, maybe a very good visualization for this question, I would end up with something like this. I would order based on count, and then I would put the numbers beside the bars instead of having a horizontal axis. So I'm going to show you a lot of figures this semester. Some are going to be good, some are going to be adequate, some may be bad. And I want you to be thinking about how you would improve my figures as I present them. I'm just a person, I have a lot of experience doing these things. I think my figures are generally very good, but I want your critical mind to be thinking through how you would improve on what I'm doing. Okay, so for the sake of time, I think we're gonna wrap up what we've done here. But these are the kinds of things I want you to be thinking about with data visualizations. Be thinking about where your eye is going. Think about the best and simplest way of communicating what's in the data. Data sets are challenging to understand without doing some encoding, like we've done here. And there are levels of quality of encoding. We've talked through some of the details for categories. Okay, so the last thing here, I guess, there's, I think, one case where a pie chart, I think, is generally okay. The standard advice, it's not the advice I give, but I want you to know the standard advice, which is to not use pie charts. So before I took the class over, in the syllabus, or in the course materials, it says, do not use pie charts ever. And you will not find pie charts in scientific communication in general. Like, you look at 100 papers, you'll find 100 papers without a pie chart. I think this advice is generally correct. You can choose to live your life never using pie charts, but I think there is one case where a pie chart can be useful. James?
Why do you say it's generally correct? Why do you say that is generally correct?
To not use pie charts?
Yeah,
So I think we just walked through a couple of examples of where bar charts are just generally better at communicating.
yeah, I agree, but I know you're about to give us an example of one.
Yeah.
Are those all the examples where you would use only a bar or a pie?
So I think most cases with categorical data, a bar chart will be easier to read, except for this one. And then I think this one, the edge may be for a pie graph. I don't know, does that answer your question?
Yeah, that is.
So yeah, the question is essentially, why do we rule out pie graphs generally? And the short answer is because bar graphs are just generally easier to read for most things, except this one. When we deal with binary categorical data, I think this is one case where a pie graph can be useful. I would say it's maybe equally useful to a bar graph, but some people may say the pie graph is more effective at communicating this one kind of question, which is, how does California compare to the whole? So we take all the other coffee shops not in California and put them in one category. And then we ask what percentage or like what proportion of coffee shops are in California. I think this one might be slightly easier to read. Stylistically, you'll almost never see this done though. Yeah.
I think they do it often, like during elections, to show like the split between
Yeah. So this is good. Remind me of your name. Erwin. So Erwin's saying, like sort of in popular culture, we do see pie graphs. In scientific communication, we generally don't. But I think this is one case where when you have two groups, so elections in the U.S. are often dominated by the two major political parties. And so in those kinds of environments, using pie graphs, I think, is visually fine. Going back to what Jackson was saying earlier, thinking about what's easiest to understand. Any questions? So this is for counts. We can also do this in terms of percentages. So I just translated everything from counts into percentages of a whole. I think this is an even better potential use of a pie graph. But this is enough, I think, for thinking about data visualization. This is kind of the basic idea with visualization is we want to make the visualization easy to understand. We have to easily understand the data using a visualization. So here's some takeaways. For binary categorical variables, where we have two kinds, pie graphs and bar graphs, I think, are both fine. When we have more than two categories, with nominal categorical data, where everything's unordered, I think a bar graph is just almost always better, at least to my eye. You can disagree. Use a pie graph at your own peril. But I think in general, you should stick to a bar graph when you're dealing with more than two categories. And then when we have nominal categorical variables, there's no inherent order, but I think sometimes it's easier to understand the data when we order by count. And then with ordinal categorical variables, really similar to nominal, it's just we definitely do want to order by not by count, but by order. So we'll talk through one of these examples in the exercise. And then some other sort of general aesthetic things. Pull out as much clutter as you can. So if you're doing something twice in the figure, like we did by putting the numbers on the end of the bars, just remove one of the duplicates. So I took off the axis because the numbers were already on the bars. And then keep it as simple as possible. You're trying to communicate something. Don't try to communicate too much. Keep it very simple. Okay. So here's what we've done. The basic framework with any visualization, any summarization technique, follows this three-step process. We're going to do this over and over and over again. First, we pick the kind of data we pick the data we're working with by selecting it. What are in the rows? In this case, we just imported the data set. So it wasn't that complicated. We didn't filter, we didn't knock out any other variables. We just took the data that was given to us. The second thing we did was transform the data. So we essentially summarized the data. And we're gonna actually work in a lot of detail with this counting procedure in a second. We looked at the data set. You remember we opened the data set and we saw the different rows? What we were doing to create the bar and the pie was to count each state. And then the last thing we did is we turned the counts into visual elements. We did it like this. So we selected all the coffee shops for this coffee shop chain. We transformed by counting by state, and then we encoded category, so the states, as the categories. And then we encoded the count as the length of the bar or the size of the pie. Okay, any questions about this? This is our framework. We're going to keep coming back to it. This is how we organize summarizing data. Okay, y'all ready for an example or an exercise? Guess you've been working with an example. Oh, look at that. Did I tell you I had a child? All right. So we're going to work with this coffee shop's data. Okay, so what we're going to do, on your computer, you're going to run over, this is how exercises are going to work all semester. You're going to hop over to the course website, and you'll see we have the slides here, the notes, like I mentioned, we're in part 1.1. And here we have the exercise. Sometimes there'll be a recorded exercise you can use. For today, we're just going to download this data set. So if you click on the coffee shops link, that will download the data set onto your computer in the downloads folder. We're going to come back to the notebook in a second. Great movie, not what we're talking about today. Thanks for the laugh. I thought about, this is highly unethical, giving out points, like participation points based on whether people laugh at my jokes. Exactly, yeah. But I have trouble matching that with the course objectives, so I don't think we'll do that. Okay, so you can download the data set. I've already pulled it up. Here. So when you click on that link, it'll download into your downloads folder. And all we're going to do is try to summarize the data set. And we've walked through a lot of these things already, but I just want to show you the reason we're starting with Excel is not because it's the main tool we're going to use, but because it demonstrates the core principles of the 3 steps that we use every time we create a visualization, a summarization. We're going to do this manually, and then we're going to have Python do it much faster and much simpler for us. Python, one of the reasons we use Python is because it's just way simpler. Okay, so how many of you have the data set downloaded? Okay, and if you don't, turn to someone around you and ask them how they got the data set. Okay, so the next thing we're going to do is create a visualization. So let's say I just select all the data, and I know something about Excel. So I'm just going to go in, Insert. So I go up to the top, I click Insert, and then I know best practice is to create a bar chart for categorical data. So I'm just going to go over here, I'm going to click on Column, and I'm going to create a vertical bar chart right here, 2D column. Anyone know what's going to happen when I click on this? Yeah.
I know because I just did it.
Okay.
It's just going to be the graphic, but there's not going to be any bars on it.
So let's click on this. Jackson's saying it's going to look like this. Is this an effective use of a visualization? No, it tells us nothing. So what we're going to do instead is create a summary table. So we're going to try to summarize the counts by state. Before we do that, let's try to diagram this data before we actually create a category. So you have neighbors around you. You know this is the neighborhood of Mr. Rogers, right? Like the PBS station right next door. That's where he filmed everything. He grew up, I think, in South O. So turn to your neighbor, tell your neighbor something fun you did this weekend, and then what the data structure is for this data set.
What's the form of the data set? What did you work this weekend out? I mean, the tree
I think they do like Muay Thai, boxing, like all that kind of stuff differently.
It's a nominal spot.
Nominal's like,
Oh, which gym are you going to?
Yeah, right. Gym doesn't exist. No, but it's just being there and then instructor was doing so that's why I started in the summer, July. But I took, like a month or two off. I want to think I'm good at it, but then like I see all the other people there, and I'm like, yeah, I'm like really good at
Okay. What's the data structure? Yeah. Cross-section, yeah. Here we have many coffee shops. We're just checking which states they're in. There's no like measurement of time. Here there's not even an index variable because we sort of, like we could include like store ID or something like that, but here we don't even have that. It's just we have a bunch of coffee shops and they're just in a list based on location. Any questions? Did anyone say time series? It's like maybe this is a measure of the state moving or the coffee shop moving. Standing wave coffee, the coffee truck. Maybe this is like each day. No, this is cross-sectional. Great. So what do we do next? So what we're going to do is try to transform this data set. We know it doesn't work very well with what we're doing to understand the data. To understand a categorical data, we want to summarize it primarily using counts. That's most of what we're going to do with categories. Just count how many things are in each one of the categories. The first step is to find what the categories are. So I'm just going to list out, I'm going to create a new table, essentially. So these are all the unique states. So I could go through and just look for each one of the states. So I could say, okay, I see Texas, I see Washington, and so on. This is the hard way. This is the long way, where I write everything out. Anyone know a simpler way? Yeah. Remind me of your name? Erwin. So Erwin's saying, let's use the unique function. So in Excel, we have what we call functions, and you can access them with an equal sign. So this is equals, and then I'm just going to write out unique. And then I open the parenthesis. You can look into what unique does. This will bring up a little drop down here, and if you click on it, it will bring up the unique function, and you could just look for information about it if you get lost. We're not going to spend a ton of time in Excel this semester, but this is kind of some of the basics. The first thing we want to enter into this function is just the list of data that we're working with. So I have A2 through A18, and that's the different coffee shop locations. I'm going to close the parenthesis and then hit enter. So now I have a list of all of the unique states. Any questions here? Yeah.
What did you put in the parentheses again?
Yeah, so I just selected them. Yeah, so you can just click on the cells and select them. Okay, any questions here? All right, so this is not enough. Anyone know what we do next? I'm trying to summarize how many coffee shops are in each location. I see Erwin's hand, someone else. James.
To use the count function for each.
So we're going to use a count function to go through our list and count up how many coffee shops are in each one of the states. How many times each one of these unique states appears in our list. Someone want to follow up on James? What's the function we use?
Count
Okay, countif. And there might have been others
Yeah,
as well.
You can use count if, or you can just use count if you like. My count if would be preferable.
Yeah, so in my notes I have countif, and yeah, I think count could work as well.
Count if is preferable. I forgot about count if.
Nice. Yeah, so James is agreeing. Let's use countif. So I'm just going to write out count here. So we have some Excel wizards in the room. So counts. I'm just going to start with the first row here. I'm going to say equals and then count if. So this is, you can again look at the function by clicking on this if you want more. So the first entry into countif, I know this because I've used countif, but if you need more information, that's what that link is for. The first entry is just the list of the things we're going to look over. So again, I'm just going to, in the parenthesis, in the first entry, I'm going to write in the array, the list of data that I want to put in. And then the second thing is I'm going to, in that list, I'm going to give it a criteria to look for. So in that list, it's going to go through and check each one of the items, whether it's equal to a certain thing. And that certain thing, the criteria, I'm just going to select Texas to start. So it looks like this. If I hit enter, it's just going to go through and count how many times Texas appears in the list. You can do this manually if you like, but this is, in general, we want computers to do the work for us so that we don't have to actually count stuff. Okay. So this is for the first row. Anyone know another thing we can do to make this easier for ourselves? Yeah.
You can click the small box in the bottom right-hand corner and drag it down. It'll produce the same action as the first cell.
Okay, great. Remind me of your name.
Darius.
So Darius is saying, let's click. If you hover over the bottom corner, you click and you drag. This will fill in the rest of the boxes. I see a lot of you ready to go with some comments about this. This is the first kind of action we'll take. And we're going to do this, and then we're going to change it slightly. So I'm going to fill all of these in. To check whether this is correct, this is definitely a great time-saving device. But I'm going to double-click just really quickly on California. If you double-click on the function, it'll bring up what it's doing. So it's going to visually tell you the array and the criteria. So first off, we can see the criteria is right. So this is California. Anyone notice something strange about the array? Yeah.
It moved down 2 cells as the
Nice. So as we've moved our function down, we've correctly moved down California. But one of the things that we've also done is moved the array down. And that's, so then if California was appearing in the top, we would have not counted those. So we're going to update this copy and paste procedure to make it so that the array doesn't move. Someone tell me, how do we do that? Erwin and James. Erwin? So a $sign after A. So I'm going to delete these entries here, and I'm going to put a $sign after A. So the $sign going in front of the number tells Excel when we copy and paste to not move the number. So it locks the number in place. So I'm going to put it in front of both the 2 and the 14. When I hit enter and then follow Darius's procedure here, we get something that looks like this with the array locked in place. Yeah, very nice collab. This creates a summary table of the counts, coffee shops by state. Any questions here? All right, one last thing. this is nice. This is a summary table, but I would say summary figures are better than summary tables. So I'm going to highlight the data, go into Insert, go over here to Bar Chart, click on the bar chart, and create a figure that looks like this. Turn to your neighbor, make sure your neighbor got a nice figure. We'll take about 2 minutes here, and then we're going to come back together and do this much, much simpler in Python. Make sure your neighbor got this. Pandas and matplotlib.
Got it.
We're actually going to use Seaboard, which I think will be a little bit nicer. You use matplotlib?
Yeah, we were using it on a board for another class.
Nice. Yeah, yeah.
We were like all locked in on it.
Nice. Yeah, we're going to do visualizations that way most of the semester. Okay. So for the exercises, exercises are generally going to have something to submit on Gradescope, just so we all stay on track. Here, the way you submit to the exercise, you can just right-click, drop down to Save as Figure, Save as Picture, and then you can save it in your Downloads folder if you wish. So we could call this Exercise 1.1, save it, and then it'll appear in your Downloads folder. So this is how we save figures. I think if you're working with Excel in the browser, I think that's a little bit more challenging. I had a student after class earlier have some troubles not using Excel on as an app on the computer, but in the browser. So if you have trouble with that, just let me know. Oh, look at that cute baby. Any questions here? Yeah.
Sorry, how did you export the graph?
Yeah, so if you right-click on the figure, you can save as picture.
All right.
Any other questions? Okay. Anyone feel tired of working in Excel already? Wouldn't it be nice if there was a procedure that could generate a summary table automatically every time? Let me introduce you to Python. So we're going to get into some of the basics of Python, and then we're going to create a figure in Python very simply. I looked at the survey, and most people in the class are not confident at all in Python. That's the baseline. If you have more than no confidence in Python, I'm glad you're here too. But we're going to talk about Python from the ground floor. So I'm going to tell you some of the very basics. We're going to talk through how we use those basics to then work with data and create nice visualizations. All right, so I'm going to close out Excel. We're going to essentially perform the same operations, but in Python. So every time we have an exercise that involves a notebook, I'm going to give you a notebook link. So I'm going to click on this link. If I click on it, it opens a browser tab. And this tab has what we call a notebook in it. Google, thankfully we live in 2026 for this reason. We can work with Python directly in our web browser, hosted on a Google server. This is what we call a Google Colab. So if you can find more information about Google Colab just on the internet. So Google Colab, and find more information about what Google Colab is. But essentially, it's just it's like Google Drive, but you can work with notebooks in the browser. So there's more information here if you wish. You can look around. The main idea with a notebook is that we can write both English and we can write code in the same environment. A notebook file is separated into two types of cells. A notebook file is just a bunch of cells, and there are generally two types of cells. One is just text, and the other is code. So we have two types of cells here. Before we get started talking through the details of exercise 1.1 in the notebook, how many of you have Google Drive set up already? Like a personal Google Drive account? If you have a Gmail account, you by default already have a Google Drive account. What we can do, every time you have an exercise like this, you can go up to File, and then drop down to Save a Copy in Drive. If you click on this, it will save a copy of this on your in your Google Drive account. I'm going to show you where to find it. So follow along as I do this. Save a copy in Drive. If I click on this, it says it's creating a copy, and then it's going to load the copy in Google Drive. Now, if I go to drive.google.com, this is my what my drive looks like. You can find a Colab notebook folder, which was just created for you, which will store all of the Colab notebooks we work with in this class and in any other class you take where you work with Colab. If I double click on this, this was from earlier, so I'm going to move this to trash. This is what should appear for you. This is a copy of, and then it gets cut off. I'm going to rename this. This is just the copy of the exercise you just created. We're going to spend a lot of time working with notebooks this semester. So I recommend every time we work with an exercise, you keep a copy of that in your Google Drive. This will help you keep things organized. You can always go back and look at the exercises I post on the website. But it's better for you to have a copy, just a record. By the end of the semester, you'll have everything in one place. So every time we work with one, save it, and then you can rename it, exercise 1.1. So that's here. How many of you were able to do this? Nice. This is one of those basic skills that it seems trivial, but if you do it every time, things will become much easier for you as the semester progresses. We're going to do this so many times. Having it all in one place will make sure you don't lose any materials. Okay, very nice. So let's talk through some notebooks. So the first thing to know about a notebook is that it is made up of cells. The first, and you can see just visually what the cells look like. This first cell is just the title. So this is just a text cell telling you what's in the notebook. So here I double clicked on it. This is not a hashtag. It just tells the notebook that this is a bold header. And you can change the size of the headers if you like. The main idea here is just that this is a text cell, and you can make changes to it. Okay, and then it'll show up. Any questions about that? Text in notebooks. I like to add text just so I know what I'm working with and keep things organized. The second kind of cell is a code cell, and these are the kind we can actually run. Python is a pretty big package, but there's so much extra packages that you can use with Python that we don't actually include everything that you use in Python in the core Python library. Instead, what we do is we import the stuff that we need when we need it. It's like I don't carry around my cast iron skillets, my mattress, my dresser when I come to work, right? I leave that at home, and I only use it when I need it. The same idea applies with Python. We're going to import a lot of things when we need them. Some of the core packages we use are listed here. So I've just called this imports. This hash sign is just telling Python to not run this line. So this is what we call a comment. So this tells Python to not run this line. The first line that runs is this one. I'm telling Python in this line to import a package called pandas. This is not the charismatic megafauna my biology professor talked on and on about. This is a portmanteau of panel and data. So we squish those words together and call it pandas. And then in college, my friends called me Tay-Tay. This was before, no, Taylor Swift was a thing back then, but she took my name. Just like my friends called me Tay-Tay, we're going to call pandas by a nickname. And the syntax for this is we're going to say import pandas as, and then we're going to give it a nickname. And you can give it whatever nickname you like. The standard one is PD. So this is what we're going to use. Import pandas as PD. But if you wanted to, you could call it whatever you like. Okay. The reason we do this is because people are lazy and don't want to write out pandas every time. So we just write out PD. And then there's some other imports here. This one is very important. This is matplotlib. It's a visualization package we'll use sometimes. There's a dot operator, which just tells Python to look in this package. And then within that package, there's a separate package. It's like you're unwrapping Christmas presents, and there's a Christmas present inside the original Christmas present. So it's like boxes inside boxes. This just says pyplot is a box inside the matplotlib box. And we're going to call that inside box PLT. Another one we'll use is Seaborn. We'll call Seaborn SNS. And this is for visualizations. NumPy is just another portmanteau of numbers Python. We call this NP. So this is how we handle imports. We're going to use a lot of imports this semester. Generally, I'll give them all to you at the top of the notebook, just so you can have them without a lot of work. The second thing we have here, so I have another line, another comment. This is file path. We're going to talk about how we handle text in Python in a second. But this is just saying I have a variable file path that I've defined using this equals symbol to be this set of characters. This is just it's like in your browser, you have a website link or a website address. This is just the address on my personal website, so taywide.github.io, for the course page, ECON 0150. And then we're looking in part 1.1 for the data set we're dealing with in exercise 1.1. So this is just something I'll generally give you to tell you where the data set lives on my website. But I'm going to show you a few extra things about Python before we get in, because there's a lot that you can explore with Python, but there are a couple of core ideas that we'll need to do our stuff for today. We have 5 minutes in class, so we're not going to get through all of these exercises, all the data sets, but I want to show you a few basic things. So my first name is Taylor, if I haven't told you that already. So I'm just going to define a string, what we call text in Python. We can set variables to any kind of object we like. So I'm just going to say my first name. This is just a variable. So first name is what we call a variable in Python. And then we're going to define what that variable is equal to. So just like in math, you say x is equal to some number. all we're doing in Python is just setting x to be something. Here, we can set it to be whatever kind of Python thing we like. So in this case, I'm going to set it equal to my first name. So Taylor. Nice. So I'm going to run this cell. I'm going to run the first one. But I can run a cell simply by clicking on the play button. Or you can hit, if you're on a Mac, you hit Command Enter to run the cell. Or if you're on Windows, you hit Control Enter, and that will run the cell. And what running the cell does is tell Python to actually execute this. So it's like it now knows what's in the cell. I'm going to hit the plus here to create another code cell. And then I'm just going to write out first name. And this will ask Python, what does this variable mean? So I'm going to print this off. And it tells me that first name is defined as Taylor. You can do this for yourself. You can change a bunch of things. Let's say I change first name to Tay-Tay, but I don't run it. I'm going to run this second cell. How many of you think this is going to say Taylor when I run this again? How many of you think it'll say Tay-Tay? Mostly correct. If I run this again, it'll say Taylor, even though this cell says Tay-Tay. And the reason is because I haven't told Python to update first name as Tay-Tay. It's still thinking it's Taylor because I haven't actually rerun that line. But if I do run this again, and you can see it's now updated with a green check mark, and I run this, it's now Tay-Tay. Any questions here? Another important idea is that we can add strings together. So what if I want a first name and a last name? Gemini is giving us these code hints. We'll talk about AI and how to use it in code in the next couple of weeks. But I'm going to say last name is Weidman. I'm going to put a space at the end. You don't really need to. So I'm going to run both of these things. So first name plus last name. And when I use this AND operator, this plus operator, that will add the two strings together. And when I do that, it looks like this. Tay-Tay Weidman. Okay. Any questions about this? So, yeah, Casey.
Could you add a space between your first and last name, or how would you separate?
Yeah, yep. So you can put a space here. If I run this, then I have space. Or I could have a space character added in between. There are more fancy ways of doing it, but those would be the basics. Any other questions? So these are simple things. I'm going to hold you for 2 minutes. Although last class I did take you over 2 minutes. Let me show you one more thing, and then I'll let you go. The next thing is just math. So I'm going to say x is equal, so this is just another variable. Doesn't matter what the variable name is. X is equal to, let's say, 2. If I print this off, I get 2. But let's say I want to add two numbers. So I have x and I have y. I've defined both of them. But let's say I want x plus y. And I run this, I get 5. I can do all sorts of things. In the numpy package, so let's say I want to take the cosine, I can say np, which is the numbers Python package, and then I want cosine. I want the cosine of x plus y. I can just run this, and I get this number. So Python allows us to do lots and lots, sort of an infinite number of these kinds of things. We're going to spend a lot of time working with code this semester. The last thing we're going to do today, I'm just going to show this to you and then you're out the door, is open a data set and call it shops. This is the file path. on my website. This is the file name, coffeeshops.csv. We're going to use pandas to read the CSV and then call it shops. And then shops.header, or we can just print out shops. So just like we did with numbers and with strings, we can also use Python to interact with data sets. So here, this is the data set we were working with in Excel. Okay, I'm sorry to have run over class twice. How rude of me. I'll give you back that time. You can upload the Excel figure to GradeScope for the exercise today, and we'll pick this back up on Thursday. Stay warm, stick around if you have questions. See you all on Thursday.